All right, so systems linear equations. So we are just looking at linear ones today. When we talk about the solution to that system, it needs to make sure we'll be checking our answers, make sure it actually works in both equations. You guys should always, really, when you're doing your web assignment, you should already know if your answer's right before you even go to type it in. So really shouldn't be any reason that you are using more than one of your chances on any problem. So we are looking at linear ones right now. We will look at non-linear ones later, which would be something like if we looked at like a parabola, and see how it compared to like maybe like a square root function or something like that. And so, what we're looking for is that place or places where the graphs cross. So those would be the solutions to that system. Here we see the one solution to this system. When you find the solution to a system, you're finding the point where the lines or whatever cross. And so, what else could possibly happen is that, of course, the things don't cross. And so then that would be no solutions. Or the lines, if they were both lines, could lie right on top of each other. So this would be that case where there's infinite solutions, because you're looking for the points where they touch, and they're always touching. So, but with lines, those are the three ways it could possibly happen. So, and we'll head off into the other realms later. And certainly, one of the ways that you could do this would be to graph them. But graphing can be kind of cumbersome because you need special tools to graph. Right? You need graph paper, you need a straight edge, all that stuff, which aren't things we often have around. And graphing can be inaccurate because we're looking for that point where the lines cross, and we can see that pretty easily here. This is 4, 3. But if the lines don't cross in a nice space, if they crossed here, we can't really very easily identify what that point is. So graphing can be cumbersome. Graphing can also be very inaccurate. But it is very nice visually to understand, like, hey, these lines are crossing. I'm finding that point where they cross. It's a really good idea to keep a hold of in your head, like, what are you actually doing is finding that point where they cross, but it's not always the best way to try to go about doing it. So, if we want to graph lines, we need to have them, or we would like them to be in slope-intercept form. And oftentimes they aren't. So if we want to do a problem like this graphically, we'd have to rewrite the equations first, which isn't too big of a deal. But it is some extra work sometimes. But of course, if we were going to do it, you guys won't be doing any of this, but just that idea that, our y-intercept, there's that. Our slope is 2 over 1, so rising 2, running 1. And so we see it's that line. Here's our y-intercept here, so there's that guy, running, or rising 1 and running 4. So we're looking at that point where they cross in 4, 3. And so just that idea, how do we check our answer? We think that's the right answer. You're just going to be plugging those back in. So, of course, make sure that's your x value. The WebAssign will ask you guys always to write your answers as order pairs like this. Just start to think about that, but checking it, right? 3 is y, so that'd be 3 equals, and then x is 4, so 2 times 4 minus 5. 3 equals 8 minus 5, which of course it does. And then checking the other one, y is 3, so 1/4 times x, which is 4, plus 2. So you always check both equations. You never do any solving. It's always just about simplifying the sides. So leave that 3 alone. 1/4 of 4 is 1 plus 2. Of course, 1 plus 2 is 3. So you can see that 4, 3 does satisfy both equations, the way we say that. 4, 3 is a point on both lines. There are many, many, many points on this line. And in the same way, there are many, many points on this line. But that is the only point that's on both lines. Okay. So we'll be checking our answers as we move forward. And as far as algebraically goes, there's 2 ways to solve a system. So substitution and elimination. They both have their benefits, and they both have their shortcomings. I think most people probably all the years I've taught this, most people prefer elimination. I prefer elimination just as a method in general. But in the end, like your overarching goal, guys, is try to find the easiest way to solve any of these problems. I know some of the problems will say use this method, or other method, and some will just say solve. And at that point, you guys get a pick. You really want to say what's going to be the easiest. When I look at this problem, what's it telling me to say, okay, let's go this path versus the other path. They both get there, but it's the kind of the journey on one will be a lot easier than on the other usually. So, okay. With substitution, what we want one of the variables in one of the equations to be solved for. That's kind of the ideal problem, is when one variable is already by itself. And so we can see with this one that y is already by itself. So this problem is kind of set up perfectly to do a substitution method with. There's that idea that once you know what y is, you can substitute it into the other equation. So we're going to replace that first y with that expression x plus 2. And so it's a good idea when you substitute something in to put parentheses around it, just in case, in this case, there's nothing here in front of there besides the 1, so we don't need to worry about the parentheses. But if that had said 2y or something like that, we'd make sure we distribute first. But here we just ignore the parentheses since there's no distribution to do. So just combine those like terms. The rest should be pretty simple algebra to solve. So I'll subtract 2. Divide by 5. Normally I tell you guys to leave things as fractions, but I think since we have some more math to do, turning that into a decimal is going to go ahead and make things a little bit simpler. If this was some sort of repeating decimal, like if it's 2/3 or something like that, I probably wouldn't do that. But since 2 divided by 5 is just 0.4, it's easy enough just to deal with 0.4. But if it was some repeating decimal, I would leave it as a fraction because we don't want to round right now. But we do need to find x and y, not just x. So once you find one of the variables, go back and look again which equation is going to be easiest to find y for. This one says y equals, so that would be the easiest. Both will work, but that'll be the easier of the two. So y equals x plus 2. So just found x was 0.4. So y equals 2.4. So that should be our answer, x, y. So 0.4, 2.4 should be our answer. Let's check it before we move on. So 4 times x plus y is supposed to be 4. 4 times 0.4 would be 1.6. And 1.6 plus 2.4 is 4. You can see it works in the first one. Always check both. And so 2.4 equals 0.4 plus 2. You can see that one works. I don't need you guys going down all the way, but once you get to that point where you can see that it's like that last step, I'm okay if you guys stop there. So here we see like a problem that would not have been easy to do graphically. What we're seeing is that the lines are going to do something like this. So just finding that point here, like there's that point. So you guys don't need to draw that part, but just again showing you what you're up to here, find that point right across. So that's the substitution method. Again, if one of the equations is already solved, it's generally the easiest way to go. The elimination method, and generally people like this one better, but it is a matter of opinion. What we want here is we want one set of variables to have opposite coefficients. And once we do that, once we have that, then we add the equations together. No, in the WebAssign, it kept saying like use the elimination method, sometimes called the addition method. It kept saying that over and over again. So I don't think I've ever heard it called the addition method before, but addition is part of the process, so it's not surprising. So we want either the x's to have the same opposite coefficients, or we want the y's to have opposite coefficients. So looking here, trying to see like what would be opposites. I could make this into a negative 7x pretty easily by multiplying that whole equation by negative 7. And that would give me opposite x's. But what I notice is that this is already positive and this is already negative, and I could take advantage of that. If I could make this a negative 2y, I could do that by multiplying here everything by positive 2. So if our overarching goal is to like do this the easiest way, then multiplying things by positive numbers, there's less likelihood that we're going to make a mistake than multiplying things by negative numbers. So it's not that multiplying negative 7 is hard, it's just harder than multiplying by 2. So I want to do things the easiest way, multiply that bottom equation by 2, and then these will cancel. They'll eliminate. So trying to find a way to make them opposites. So that would give me 14x minus 2y equals 38. I'm just going to bring the first equation over. I tend to do better, looking just like straight down rather than having to like get this one and then compare it to this one over here. So just take a couple extra seconds and write the original equation down. But once you can see that those are going to eliminate, and you just add everything else. That'd be 15x's, and 38 plus 7 is 45. So divided by 15, x is 3. Once you have one of the variables, plug it back into one of the equations. Again, which one is easiest, right? Do you want to use the first equation? Do you want to use the second equation? Doesn't matter. And just plug it back into one of them. See what y is or whatever the other variable is. So I'll just use the first equation. So 3 plus 2y equals 7. Subtracting 3, so 2y is 4. So y must be 2. And write your answers in order pair, so that's 3, 2. And then check your answer. 3 plus 2 times 2 is 7. 3 plus 4 is 7. Check. 7 times 3 minus 2 is 19. 21 minus 2 is 19. Those are the two methods. I mean, no matter if you're doing word problems or if you're doing systems with 3 variables, 4 variables, 5 variables, these are the methods of solving algebraically we have. And so really what it comes down to is, which one's the best for you? At any given problem, what are you seeing that says, hey, I should go down this path versus the other one? Always wanting to try to do things the easiest way possible. Because they'll both always work. Okay? Graphing would always work. One of these would always work, but which one's going to be the easiest? Really, where you guys want to, that's the problem solving side, guys, is like, I look at this, this is what I see, it makes me want to do this versus do the other thing. So that's the most applicable thing you guys could be thinking about is just decision making. What's going to drive my decision here? So you guys think, should we do elimination method here or substitution method? Why is that, Grant? Don't say they. What are you talking about? The equations have opposite signs? Be more specific.
The Y's.
There. So Grant's saying that he should do elimination because the Y's have opposite signs already. So if we want those to be opposites, what number would we look for, Grant? How are we going to get those Y's to be opposites? Okay, to get what? What number are you talking about? You got some goal in mind. You want them both to be what? You said multiply by 4 and by 3. What are you going to get? Now, what's the answer? Like, you have some goal in mind. You picked those numbers for a reason. Why did you say multiply by 4? Why did you say multiply by 3? Negative what? Multiply by 3 by 4, Grant. Right. So Grant's wanting to get 12 and negative 12. Okay, seeing that that'd be opposites. Okay. Yeah, we could have 10 and negative 10. There's nothing stopping us from doing that. We can multiply this by negative 5 and this one by positive 2, or this one by negative 2 and positive negative 5. But again, are we going to make more mistakes doing that? Chances are yes. Right? Plenty of you that can go through and multiply by negative 5 and be just fine. And you could do that 9 out of 10 times and be just fine. But there's just that one chance you miss your negative and it screws everything up. So least likely to make mistakes by multiplying by 4 or multiplying by 3. So. But by far the easiest thing to do, guys, is miss some distribution. All right, so just be really careful about your distribution. So 8x minus 12y. You know, when I was doing this one last night, I said 4 times 7 was 21. So that definitely screwed everything up as I was trying to move through the problem. So watch your distribution. We get 15x plus 12y. And that's 51. We know those two will cancel. 8 plus 15 is 23. And thankfully, 51 minus 28 is also 23. So x is 1. So once you have x or y, it doesn't matter, we just keep having to get, it seems like we've got an x every time here, but it's just a coincidence. Plug it back into one of the equations. The other one, I'm going to use the first equation. So yeah, y is 3. And right transfer is an order pair, so 1, 3. And then we'll check it real quick before we move on. So 2 times 1 minus 3 times 3. 5 times 1 plus 4 times 3. Do right, Tiger. Do not, Ruth. Do right, Katie. Sorry, this one's kind of like squished on top of itself. Trying to separate there, but what do you guys think here? Method should we use? Multiply the top by 5. What's your goal there, Maddie?
To get 1 over y in the top equation to be 5 over y.
So you want the 1 over y in the top equation to be 5 over y. So trying to make those opposites. So we multiply the top equation by 5. So okay, that way we can cancel those guys. Okay. Definitely sounds easier than trying to get x or y by itself. So we get 5 over x plus 5 over y equals 40. So this may look intimidating, like 5 over x plus 3 over x, but it's actually really simple. 5 over x plus 3 over x. Right, if it said 5 halves plus 3 halves, that would just be 8 halves. So 5 over x plus 3 over x is just 8 over x. Of course, 40 plus 0 is 40. What's next? Kobe, I can see you yawning behind your mask. I can see you yawning behind your mask. Multiply by 8. So if we multiply by 8, we would get 64 over x equals 320. That didn't help. Multiplying by 8 is not going to help us. Multiply by x. So 8 equals 40x. Divided by 40. So 40 divided by 8 is 5. 8 divided by 40 is 1/5. So I'm going to plug that back into the top equation just because that one doesn't have any coefficients like the 1 and the 1 versus the 3 and the 5. So this one's a little tricky. So I got 1 over 1/5 plus 1 over y equals 8. So this right here, right, division by fractions is not something we're generally very good at thinking about. So it kind of leads me to one of my favorite questions to ask students: what's 10 divided by a half? A lot of times we say 5, but we got to know that's wrong. 10 times a half is 5. 10 divided by a half. What's that? Yeah, 20. Because we're not supposed to divide by fractions, we're supposed to do what? Multiply reciprocally. Because we just don't understand division by fractions. It's not that we can't divide by fractions, we just don't understand it. Right? So, but really what it comes down to is when you divide a number by fractions, like if I say what's 10 divided by a half, I should take 10 things, cut them into halves. If I take 10 pieces and cut them into halves, I have 20 pieces now. Right? So if I take one thing and I divide it into fifths, how many fifths are in 1? Right, Katie, 5. There's 5 fifths in 1. That's what a fifth is. It's a fifth of 1. There's 5 fifths in 1. So 1 divided by 1/5 is 5. There are 5 1/5ths in 1. Just like there's 3 thirds in 1 and 4 fourths in 1 and 2 halves in 1. That's what it means to be a fraction. Right? So we just don't think very well that way. So instead we've come up with this trick of multiplying by a reciprocal. But you can divide by fractions. It's just harder to think about. So this is equal to 5. So 5 plus 1 over y is 8. So 1 over y must be 3. So again, we could solve this the same way we solved this, or we could think about it. If 1 divided by 1/5 is 5, 1 divided by what is 3? 1 divided by 1/5 is 5. 1 divided by what is 3? 3, yeah. Right. If I want 3 groups out of 1, then each group would have to be the size of 1/3. Right? If I want to get 3 things out of 1 pizza, each would have 1/3 of a pizza. Okay? So there's our answers, right? 1/5 and 1/3. X before Y. Just trying to understand a little bit of fraction math, like how that actually works. It's not something we spend a lot of time talking about. Let's check that real quick. And 1 divided by 1/5. How many fifths are in 1? There are 5 fifths in 1. How many thirds are in 1? There are 3 thirds in 1. Of course, 3 plus 5 is 8. And when you go do the other one, 3 divided by 1/5 plus, minus 5 divided by 1/3. It's supposed to be 0. So if there's 5 fifths in 1, that means there would be 15 fifths in 3. That's equal to 15. And if there's 3 thirds in 1, that means there'd be 15 thirds in 5. So 15 minus 15 being 0. Yeah, but if you're going to try to type this into a calculator, you got to make sure you type it in the calculator correctly. You have to do 3 divided by, 1 divided by 5 in parentheses. So just typing it this way will give you the wrong answer. I won't give you the right answer. You have to do it this way. Again, fractions and calculators are tricky, just like fractions and humans are tricky. So, see that it works. Anything with the normal cases you guys want to go back over real quick before we look at the special cases? You good, Claire? So with these, you can just think what would be easiest, right? You want to get x by itself, you want to get y by itself, you want to try to eliminate x's, you want to eliminate y's. They're kind of saying, hey, why don't you get x by itself? Because there's just one more step to do here. You might be, tempted to do that. One thing I would say, no to that is when we go to divide by 6, those fractions are not going to reduce into nice fractions. Like that would become 10 thirds, and that would become 2 thirds. Then having to take that expression and plug it back into here would be a little bit messy. So I try to avoid fractions if I can. So just seeing that 6 is there is going to say, never mind, I won't do that. So I say, okay, we got to do elimination then. But this problem's not set up for elimination because here the x and the y are on the same side, here the x and y are not. So if I want to do elimination, they have to look the same first. So that's going to tell me that I need to bring the 4y over first. So again, both methods will work. If I prefer to do elimination, then I have to make sure the problem actually is set up correctly. So 6x minus 4y equals 20. Let's bring that first one over. Why is that? Yeah, I just brought the y over. No, I don't have opposites here. I don't have 3 and negative 6 or anything like that. I don't have opposites here. They're the same. So I've got to do something to get them to be opposites. So, if I see here, I'll just deal with the x's. If that was a negative 6, I'd be happier, right? So I'll just multiply the x by negative 2. So that gives me, negative 6x plus 4y equals negative 24. Hopefully you kind of see why it's a special case. Now that I've done that, not only do the x's cancel, but the y's also cancel. So we get 0 plus 0 equals -4. And of course, 0 doesn't equal -4. That's our false statement, which means why that's happening is because the lines actually don't touch. And we're trying to find the place where they touch. They don't touch. So this would be our no solutions situation. So when the variables both cancel at the same time and you end up with a false statement, that's your no solutions. And look at the last one of these here. Again, do you want to try to get x by itself, which would be pretty easy here? You want to try to get y by itself here, but be so bad. Again, I'm just kind of a fan of elimination method. Can I get the x's have the same coefficient or the y's have the same coefficient or opposites? Looking at that y, I could make that a positive 4y pretty easily. So that's what I would do, but you can always do it a different way. So to make that a positive 4y, I need to multiply by a -4. And easiest thing to do when you're doing these guys is to make a misstep on your distribution. So just really be careful about that. -4 times positive 1/4 would be -1 x. And -4 times -y would be positive 4y. -4 times -4 would be -16. Again, it's a special case because you should notice that both variables are going to cancel again. So on the left side, we get 0 plus 0. On the right side, we also get 0. Those cancel. 0 equals 0, which is, of course, true. I think another pretty common mistake is I've had students say, well, the answer must be 0. Right? X equals 0 is my answer. And then you plug 0 in, and you go and figure out what y is. You figure out whatever y is, then you go and plug that answer in, and you see that it works. Well, yeah, it does work because there's an infinite number of answers. Okay, so if you just say that 0, -4, whatever your answer works, then you're missing out a whole bunch of other answers. So just paying attention if the variables cancel, that's something special. So there's not an answer, there's many answers to this problem. So that'd be our infinite solutions. So it doesn't matter if it says 0 equals 0, if it says 4 equals 4, or 12 equals 12, or -23.7 equals -23.7. Just that they're the same. There's no x, there's no y, but both sides are the same. So there's no point in checking either one of those, because either it won't check ever or it'll always check. So as long as you're confident in your step you've got until you get there, you should be fine. Why that happens is because the lines are right on top of each other. Usually what we see, like as far as the drawing goes, is 2 sets of arrows. We're just seeing that there's all these points where they touch. So I don't want to do the word problem. You guys don't have any word problems in your work, and then we'll get to applications a whole bunch when we're doing the matrices, so we'll save that for later.